The objective of this demo is to demonstrate the path transition animation. I'm just going to go ahead and run what's in the textbook to do this, which is relatively straightforward, but then we're going to embellish this a bit and make it a little bit more interesting. Basically, all that happens is we have a path that's defined to be a straight line, a vertical line. Think of it as a flagpole, and we have a picture of a flag that's being hoisted up the pole. So here's what it looks like. You'll notice that it auto repeats, and that's a symptom of what it says right here where the cursor is, pt.setCycleCount 5. In fact, it's going to go hoisting up that flagpole a total of 5 times before it stops. I don't know if we want to actually watch it, but I guess it's near the end, so why don't we just go ahead and confirm that after the 5th hoist it stops. I'm not sure, but I think this is the last one here. Yeah, and now it's all done. Well, rather than look at the code that's doing this, let's just go ahead and modify this to make it a little bit more interesting. I'd like a path that's not a straight line, so I'm going to use a polyline to do that. In fact, I'm going to make it in the shape of a sine wave just to make it a little bit more interesting. So let's go ahead and make some changes to the code. First of all, I'm not too fussy about 5 repetitions, so let's make this 2 so we can see it do 2 passes through the path that I'm going to specify. I suppose we should look at some of the other parts of the code. So this is stuff that you've seen before. We don't need to go through it. And the stuff up here, we don't need to go through again. We create a pane for our animation. And then we create an image view. You remember what that's about from chapter 14. And we're going to use that same little image of the US flag that was used in the original demo here. We're going to drop that image view into our pane. And then what we need to change, of course, is the path. Instead of just a line that goes from 100, 200 to 100, 0, we're going to put a polyline in there instead. That means I'm going to have to do another import up here. I guess I'm probably not going to have to use a line. So what I'll do is I'll replace this line instead with polyline. And then I'll actually create myself a polyline right about here, I guess. So polyline, I'll call it PL equals new polyline, and I'll make myself an empty polyline. And then what we'll do is we'll make a couple of double variables up. One will be an angle, the other will be an x and a y value. Remember I said I was going to do something that was a sort of a sine wave. So to do that I'm going to need a for an angle, and from that angle I'm going to calculate the sine and cosine to determine the x and y positions. Well, actually the y value will be the sine, and the x will just model the a linearly. So as the angle increases, x will just increase linearly along a straight line. So that'll represent the x coordinate, and the y will be the sine of the angle as this progresses. So to calculate all of these points that are going to be involved in the path, I'm going to set myself up a for loop. And we're going to say for int I equals 0, I is less than 100, I plus plus. So I'm going to have a 100 point path for my object to follow along on. Now I'm going to want a couple of cycles of a sine wave when I do this. So to get that, what I'm going to do is I'm going to calculate an angle based on first of all 2 pi, which would be a complete cycle, multiplied by I divided by 100, but divided by 4, and therefore I'm effectively going to get 4 cycles of a sine wave representing this path. So in other words, my angle will be equal to 2 times math dot pi times I divided by, now if I just did 100 here, I would get one single cycle, but instead I'm going to divide by 100 quarters so that I wind up with 4 such cycles. Now for every angle, I'm going to calculate y as being equal to minus math dot pi multiplied, or sorry, math dot sine of the angle, and I'm going to multiply that by 100 just for scaling, because the sine function only goes from positive to -1, but multiplying by 100 is going to make it have a larger range, and I'm going to offset it by 200 so that it actually never goes negative. Now in the meantime, the x value in each case is going to be 250 multiplied by the angle divided by the quantity 2 times math dot pi, because as I said, I want this to sort of be a linear increase in x with each step, but I want it to be large enough to be meaningful in the context of the number of pixels that are going to be represented on the screen when I do this. So that will actually do the job, and this will then generate a series of xy points that I can add to my polyline. Now I have an empty polyline called PL right now, so if I do a PL dot get points, this will give me all the points in my polyline so far, and of course there's none initially because my polyline starts off empty, but now I'm going to add to it the x value in this case, and I'm going to do the same thing with the y value. So why don't I copy and paste that code and change that to a y. So the polyline is supposed to be alternate x and y values. So that'll actually do the job of generating my polyline for me. I'll plot that path for you so you can see what it looks like, but I won't initially because we'll just go ahead and run the demo on it so you can see that yes, the flag's actually following that shape through. So right here, instead of putting in a new line, I'm going to put in my polyline PL. Now the rest of the code that we haven't talked about yet is just that we do a path transition PT, we define a path transition called PT, and we give it a duration of 10,000 milliseconds, which is 10 seconds. And then we give it a path to follow, namely my polyline, and we give an object that's going to follow that path, namely the image view. This line says that we're going to set the cycle count to 2, meaning it's going to repeat 2 transitions over that line, and then we start the animation playing with pt.play, and that's basically it. Now I'm going to change this the size of my scene to accommodate what I've done because it's actually too small the way it is, 250 by 200. So probably about 500 by 1,000 might be a little bit more appropriate. Oh, whoops, I think I really want maybe 1,000 by 500. So let's go ahead and try this demo out then. Here we go. See that flag is following a sinusoidal path, 4 ups and downs, and repeating. Should repeat just this one last time, 2 altogether, and then it should stop. And that's it. So now let me go ahead and drop the polyline into the scene so you can see what it looks like. Well, to do that, I guess I can borrow a line that's already here, namely this one, pane.getChildren.addImageView. Let's go ahead and copy that down to under the place where I've produced my polyline, and I'm going to add my polyline as well. Let's give that a shot and see what it looks like. Now the other thing you'll notice is it's the very center of the image view that's following that path. You might not have realized that otherwise. Furthermore, it seems there's a little bit more to the window that I should have made it a little bit bigger. So hopefully you found that a little bit more entertaining than just the simple flag raising demo.